Welcome back to my channel. George here with you again. Now today we have a fun little challenge to work on. It's called the game it. That's what I call it actually. Now it's a little piece from game theory in statistics or mathematics, and this is how it goes. They said a one level let's see. They say one level nested sequence with homogeneous length is of the form. So this is what you call a nested list or a nested sequence in general. So I have a list and then I have three lists inside of it. So there is nested. They said know that the sequence is made up of three items, 1, 2, 3 obviously. Each item, which is the inner sequence, in turn is made up of 4 items each. So 1, 2, 3, 4. Okay, we got that. They said this can be seen as a matrix with 3 rows and 4 columns. So we have 3 rows and then we have column 1, column 2, column 3, column 4. Okay, that's well understood. Now here comes the question. They said we should develop a function that takes in the sequence as its only argument, determine the minimum of each row and the maximum of each column. Then return a sequence having 2 subsequences, the first being the sequence of row minimums and the second being the sequence of column maximums. Use any appropriate data structure to implement this. They said the function should work for any number of rows and columns. Okay, and before we move down to the next part, let's see what they have here as the illustration. They say, for instance, if we have this, the row minimum are 2, 2, and 3. So let's see the minimum of this row. That's 2. Minimum of this row is this 2. For the first row, it is 2. The second row, it is 2. The third row was the minimum. That's a 3. Okay, so we have 2 to 3. And the column maximums are 5, 3, 5, and 9. So for the first column, the maximum is 5. The second column, the maximum is 3. The third column, the maximum is 5. And then the fourth column, the maximum is 9. Okay, that's what we have. So it says hence the result to I would be 2, 2, 3, 5, 3, 5, 9. Now they said we should use any data structure, so don't mind what we have here as the final result. However I want to return your result, we have to return it using any data structure we have. Okay, so whatever programming language you're using, you can go ahead and implement this in that programming language, but here I'm going to implement it in Python. Okay, later on in the future I think we are going to implement this in other programming languages, but for now we are working with Python. So let's see the second question. It said create a function that uses the result of I. Okay, so it's going to use whatever we get out of this to determine if the maximum of all minimums, which is called the maximin, is equal to the minimum of all maximums, called the minimax. If they are, return a saddle point exists, else return there is no saddle point. And they give us an example. Okay, this is the result we have from I. So they are saying from this result we are going to look for the maximum of all minimums. So these are the minimums. What are the maximum out of this minimum? It is 3. What is the minimum out of this maximum? And that's a 3 also. So in this case, since the minimax and the maximin, they are actually the same thing, it means we are going to have a saddle point exists. But if that were not to be the case, we would have said a saddle point, or there is no saddle point according to what we have here. Okay, so that's the question. So go through the question again. You can pause this video and go through this little challenge we have here. In the next video I'll be coming up with the solution to this challenge. Okay, meanwhile make sure you do it, and then if you have any issue, any complaint, any comments, you can go ahead and put it down in the comments, and I'll see you guys in the next video. Bye bye.